Hey there, math magicians. Here we are, finishing up Unit 11. This is the last lesson for Unit 11. So here we go. Let's title it Lesson 11 or 11.7. And the topic is solving rational equations. All right, so you have to pay attention to details. Rational basically means fraction. So we've been working a lot with fractions in this unit. And equations, all equations have equal signs, and that's really, really important to notice in these problems. So that's what makes them different. All of them today are going to have equal signs. Okay? All right, so your job is going to be to solve. Solve means find the value for x to make the equation true. Find x. We're dealing with fractions and their equations. Now, since they're equations, you have to keep it balanced. All right, you have to keep it balanced. And whatever you do to one side, whatever you do to one side of the equal sign, whatever you do to one side of the equal sign, you have to do to the other side. Okay? So, very key that you notice these have equals. Up to this point, we've been working with expressions. Expressions are different than equations. Expressions are like just half the problem. So, different rules. Now we're working with equations, so there's a right side and a left side. All right, let me give you the steps. So if I were you, I'd keep these steps, I'd keep my notes open while I work on my homework, and I'd keep these steps in front of me and these examples that I'm going to go through. And then kind of treat the steps like a checklist. So number one, you're going to factor the denominator first. Factor the denominator. All right, so it still follows that good old rule that we've been emphasizing, factor first. So just factor the denominator. All right? Number two, you're going to find the lowest common denominator. Lowest common denominator. So this is like very similar to adding and subtracting. So it starts out anyway. Very similar to adding and subtracting. Now, here's where it gets a little different, but it actually makes for an easier problem. You're going to multiply every term on the right side and on the left side of the equal sign, every term by the LCD, the lowest common denominator. And in so doing, you're going to cancel, and that will eliminate fractions. Okay, so you're going to eliminate the fractions. I do believe we've done this before, but not with so much algebra. All right, then from there, you'll continue to solve, but it won't have any fractions anymore. And if it's linear, those are the easy ones to solve. You just isolate the variable. And if it turns out to be a quadratic here when you're almost done, don't forget to solve a quadratic. You set it equal to 0 and factor. Okay, so there are your steps. that you'll just follow, and if you just follow the steps one thing at a time, you should be okay. All right, let's try some examples. All right, so here we go with some examples. Okay, number 1, let's go with 2x over 5 plus 1/3 equals 10. Okay, so the first step, if you look at your steps, the first step is factor the denominators. Well, can this be factored? No. Can I no. Okay, so I can't really factor this time. All right, next step is find the lowest common denominator. So between 5 and 3, what can they both turn into? The lowest number they can both turn into is 15. And then I'm going to take that lowest common denominator, 15, and I'm going to multiply every single term by 15. So you're going to distribute 15 to every term on both sides of the equal sign. Now when you do that, you're going to have some canceling. So here we go. When I take 15 times 2x over 5, 5 can cancel with 15. So in your head, you're going to go, okay, 5 is going to be gone, and it goes into 15 3 times. So then I'm just going to go 3 times 2x. All right, so when I multiply 15, 5 goes into 15 3 times. 3 times 2x, 6x. No more fraction. Now I take 15 times 1/3. Well, 3 goes into 15. 3 cancels. Goes into 15 5 times. And then the last one, 15 times 10. There's no canceling here. 15 times 10, 150. So when you multiply by that LCD, these denominators should cancel, and then you get no fractions. Now this is linear, so you just solve. Subtract 5 from both sides, 6x equals 145, and then divide both sides by 6, and x equals 145 over 6. All right? So you're canceling, getting rid of fractions. All right, let's try another one. Number 2. Let's go with 2 over x minus 3 equals 4 over x minus 7. So again, what makes these different? Equal sign. Equal sign. All right, so you factor the denominators. Well, that can't be factored, and that can't be factored. So now I think about what's the lowest common denominator. Well, I need an x minus 3 and I need an x minus 7. So the lowest common denominator is x minus 3 times x minus 7. I need them both. All right, just like when you're adding fractions, you need a common denominator. But now you're going to take that and you're going to distribute to both sides, to every term in both sides of the equal sign. All right, here we go. Now when you take this, both of these, and you multiply it by this fraction, the x minus 3's will cancel. X minus 3's will cancel, but you'll still have the 2 and the x minus 7. So you have 2 and then x minus 7 equals, now you take all of this, multiply it here. When you take all of this and multiply it by this term, the x minus 7's cancel. X minus 7 cancels, but the 4 and the x minus 3 stay. All right, you just eliminated fractions. Now just continue here. This is a linear problem. Distribute on the left side, you'll have 2x minus 14. Distribute on the right side, you'll have 4x minus 12. Let's get all the x terms on the same side, so let's subtract 2x. Actually, let's subtract 4x. Subtract 4x. And then add 14. Add 14. And then finally, divide by -2. And there you have it. Now, you do have to check for extraneous roots. All right, you have to check for extraneous roots when there are variables in the denominator. So here, remember the denominator can't equal 0. So what would make this denominator 0? X can't be 3, right? What's 3 minus 3? 3 minus 3 is 0. All right, so X can't be 3. And then when you look over here, this whole thing cannot equal 0. So this X can't be 7. 7 minus 7 would be 0. So X can't be 3 and X cannot be 7. All right. I'll start another video to go through a couple more examples.